In 2018, geneticists at Stanford University concluded a study that had been almost 2 decades in the making. They had gathered DNA from over 8,000 people covering every inhabited continent. This included hunter-gatherers in the Kalahari Desert, fishermen on tiny Pacific islands, farmers high in the Peruvian mountains, and herders from central Mongolia. Their goal was simple: to rank human groups by how much external DNA they carried. They wanted to see how much mixing had occurred and how much had remained unchanged. When the results came out, they shocked everyone. Groups often considered genetically pure turned out to be some of the most mixed on Earth. And the populations with the most genetic continuity, those whose DNA most resembled their ancient ancestors, were not who anyone expected. The number one group on that list came from a place most people couldn't find on a map. We're going to explore every level of this ranking. We'll see who mixed the most, who barely mixed at all, and why the purest population on Earth surprised even the scientists who discovered them. But first, we need to understand what pure actually means in this context. It's a word people use often, and it almost never means what they think. Every human alive today shares a common ancestor. This ancestor lived approximately 200,000 years ago in East Africa. That's not a theory, it's what every major DNA study has confirmed for the last 30 years. From that single starting point, small groups began to move. Some went north into the Middle East and Europe. Others traveled east through India and into Southeast Asia. Some crossed the Bering Land Bridge into the Americas. Others sailed across open ocean to reach Australia and the Pacific Islands. As these groups separated, their DNA started to change. Random mutations accumulated. Different traits became common depending on the climate, the food, and the diseases they faced. Over tens of thousands of years, these groups developed distinct genetic signatures. They weren't different species and not different races in any biological sense. They were statistical clusters of genetic variation that scientists can now read like a passport. This raises a central question. Who are these pure populations, and why were they so unexpected? The Stanford team measured something called genetic continuity. This looked at how much of a modern population's DNA came from the first people in that region. They then compared that to how much DNA came from outside groups. These outside groups arrived through migration, conquest, slavery, trade, or intermarriage over hundreds of years. A population with high genetic continuity remained mostly isolated. Their ancestors did not mix much with outsiders. Think of them as a closed system. On the other hand, a population with low continuity was a crossroads. Empires marched through, traders set up shop, refugees found new homes, and conquerors settled down. This constant movement brought new DNA into the local gene pool. This is where the findings become really interesting. The places we usually think of as very mixed often showed surprising genetic patterns. And populations we assume are all the same often hide centuries of migration that few people talk about. This means humanity's genetic map is far more complex than simple assumptions suggest. It sets the stage for what we found when we looked at the actual rankings. So, the ranking starts at the bottom. These are the populations with the most outside DNA. Number 20 on the list, near the very bottom of the genetic continuity scale, showed a result that surprised almost no one: Latin America. This region scored as the most genetically blended landmass on Earth. An average person in Brazil, Colombia, Mexico, or the Caribbean carries DNA from 3 major continental sources: Indigenous American, European, and West African. In places like the Dominican Republic, the average citizen has genetic markers from all 3 in nearly equal amounts. This mixing was not a slow, natural process. It was the direct result of 5 centuries of forced contact. Spanish and Portuguese colonization began in 1492. The Atlantic slave trade brought roughly 12 million Africans to the Americas. Then waves of European, Asian, and Middle Eastern immigration followed in the 1800s and 1900s. The result, genetic purity in Latin America simply does not exist in any meaningful way. But the researchers did find something shocking. Not Latin America's score, but how much indigenous DNA had survived. Despite centuries of population collapse from disease, despite forced labor, despite cultural erasure, the genetic signature of pre-Columbian peoples was still detectable in over 70% of the samples. Mexico, in particular, showed strong indigenous continuity. Some regions in Oaxaca and Chiapas registered over 90% native ancestry. The mixing was real, but the original DNA had not vanished. It had simply been layered. Number 19 on the ranking was the United States. The country built its identity around being a melting pot. It turned out to actually be one. African Americans on average carry around 24% European ancestry. White Americans carry small but measurable amounts of Native American and African DNA. The Latino population in the United States, depending on their country of origin, can show contributions from 5 or 6 different continental groups. Even the so-called founding population, the descendants of English, Scottish, and Irish settlers, slowly blended over 4 centuries. This result was expected. The American finding was not the surprise. The surprise came next. At number 18, the UK ranked lower than most people would expect. Modern English people often see themselves as coming from one old group, like the ancient Britons or the Anglo-Saxons who arrived in the 5th century. DNA tells a different story. The average English person today carries genetic material from at least 7 distinct ancient populations. These layers include pre-Celtic hunter-gatherers, Neolithic farmers from Anatolia, and Bronze Age steppe migrants from what is now Ukraine. Then came the Romans, Anglo-Saxons, Vikings, and Normans. In recent centuries, immigrants from the former empire added even more. The most surprising finding was about the Anglo-Saxon migration. Historians once thought it completely replaced the existing population. But it turns out Anglo-Saxons only contributed about 40% of modern English DNA. The original Celtic people were not wiped out. They were simply absorbed. Modern English DNA is like a layered cake, with contributions from every group that ever crossed the channel. The idea of a pure Anglo-Saxon bloodline is, genetically speaking, fiction. Spain came in at number 17. Its story is even more dramatic. Spanish DNA shows heavy contributions from North African Berber populations. This is a direct result of nearly 800 years of Moorish rule, from 711 to 1492. Add to that the Roman occupation, the Visigothic kingdoms, the Phoenician trading colonies, and the Jewish communities that lived in Iberia for over 1,000 years before their expulsion. The modern Spaniard carries genetic markers from across the entire Mediterranean basin. A pure Spanish identity never truly existed. Number 16 was Russia. Russian DNA clearly shows contributions from Slavic, Finnic, Baltic, Mongol, Turkic, and Caucasian groups. Centuries of expansion across Eurasia, combined with the Mongol invasions and the absorption of dozens of indigenous peoples, created a population far more diverse than its modern political identity suggests. There's a saying, scratch a Russian and find a Tatar. The DNA proves it. Numbers 15 through 12 were all populations from the Indian subcontinent. India scored remarkably low on genetic continuity. This isn't because Indians have mixed with foreigners recently. It's because the subcontinent has been a meeting point for ancient populations for over 50,000 years. Diverse groups like South Indian Dravidians, North Indian Aryans, Tibet tangent-related groups in the northeast, and Persian-influenced communities in the northwest have all blended. The caste system, ironically, preserves some genetic isolation within India, but the overall picture is one of constant ancient mixing. Number 11 brought a result that caught everyone off guard: Germany. The German genome is far more mixed than the country's modern image suggests. Underneath the Germanic layer lies Celtic DNA and Slavic DNA from centuries of eastward expansion and intermarriage. There's Roman influence in the south and significant contributions from medieval Jewish, Polish, and Czech populations. Europe's genetic borders rarely match its political ones. Someone from Eastern Germany often shares more DNA with a person from Western Poland than with someone from Western Germany. The nation-state is a recent invention. The genome remembers an older world. Italy was number 10. Italians are one of the most genetically diverse populations in Europe. A Sicilian and a Milanese can differ more genetically than a Pole differs from a Greek. Italy sits at the crossroads of the Mediterranean. Greek, Phoenician, Etruscan, Latin, Germanic, Norman, Arab, and Byzantine populations have all contributed to the modern Italian gene pool. There is no single Italian DNA. There are dozens of regional Italian DNAs, each with its own history. Europe's complex genetic tapestry defies simple labels, making the true pure populations even more enigmatic. The rankings now begin to climb. The populations from this point upward show real genetic continuity. Number 9 is Iran. Despite Arab conquests in the 7th century, despite Mongol invasions in the 13th, And despite Turkic migrations and Greek influence dating back to Alexander, modern Iranians carry strong genetic continuity with the ancient Persians. About 75% of the Iranian genome traces back to populations that lived on the Iranian plateau over 4,000 years ago. The cultural and political changes were massive, the genetic changes were not. Number 8 is Ireland. While the English genome layered with successive invasions, the Irish kept a much higher percentage of their original Celtic and pre-Celtic DNA. Geography played a major role here. The island was harder to reach. It was harder to hold. Viking and Norman influences, while real, never overwhelmed the native population. Even the Great Famine of the 1840s and the resulting emigration paradoxically helped preserve the genetic signature of those who stayed. Modern Irish DNA still strongly resembles the DNA found in 5,000-year-old burial sites across the island. Number 7 is Finland. The Finns are one of Europe's most genetically distinct populations. Their language is not Indo-European. It belongs to the Uralic family alongside Estonian and Hungarian. Their DNA reflects this. Finnish people carry genetic markers that connect them more closely to ancient Siberian populations than to their European neighbors. Centuries of relative isolation, combined with a small founding population, gave Finland one of the highest genetic continuity scores in Europe. Geneticists actually use the Finnish population as a reference group for studying rare hereditary diseases. Their genome is so well preserved that mutations are easier to track. Number 6 is the Basque people of northern Spain and southwestern France. The Basques are a genetic puzzle. Their language has no known relatives. Their DNA shows them to be one of Europe's oldest continuous populations, with roots stretching back to the original hunter-gatherers who lived on the continent before the agricultural revolution. While every other European population was reshaped by Bronze Age migrations from the steppe, the Basques remained largely untouched. They are, in a real genetic sense, the closest living link to pre-Indo-European Europe. Number 5 is the Sardinians. The island of Sardinia, off the coast of Italy, acted as a genetic refuge for thousands of years. Its mountainous interior was difficult to conquer. Its population stayed isolated even as the surrounding Mediterranean was repeatedly invaded and resettled. Sardinian DNA is the closest living match to the DNA of the early Neolithic farmers who first brought agriculture to Europe over 8,000 years ago. When scientists sequence the genomes of Bronze Age skeletons found in southern Europe, the closest modern population is almost always Sardinian. Number 4 is the Ainu of Japan. This is not the mainstream Japanese population, but the indigenous Ainu of Hokkaido. The Ainu are genetically distinct from both the Japanese and the Koreans. They carry ancient DNA that links them to the Jomon people who inhabited the Japanese archipelago. 4 rice farming migrants arrived from the Asian mainland around 2,500 years ago. Today, fewer than 25,000 people identify as Ainu, but their genetic signature represents one of East Asia's oldest continuous human lineages. They are, in a sense, the genetic memory of a Japan that existed before Japan. The top 3 populations are even more surprising. The top 3 populations on the list were the most revealing. Number 3 was the San people of southern Africa. Their genetic story goes much deeper than simply being less mixed than others. The San DNA actually holds the most ancient genetic roots of all living humans. Every other population on Earth, even other groups in Africa, branched off from a common ancestor more recently than the San did. If you imagine the human family tree, the San sit closest to the trunk. They are not some ancient relic. They are the source of humanity's genetic variation. Their languages include unique sounds, like clicks, that you hear almost nowhere else. Their hunter-gatherer culture still practices traditions that might be 70,000 years old or more. And here's the most surprising part. The genetic diversity within the San people themselves, a group of maybe 100,000 total, is greater than the genetic diversity of all non-African populations combined. Think about that for a moment. All Europeans, all Asians, all Native Americans on Earth have less genetic variation among them than this one small group in southern Africa. The San represent the true wellspring of human genetic diversity. Number 2 on the list was the Yamato Japanese. Mainstream Japanese DNA shows amazing genetic continuity. After the Yayoi migrants who brought rice farming from mainland Asia mixed with the indigenous Jomon people about 2,500 years ago, Japan's genetic makeup largely settled. It didn't change much after that. The island's geography, along with long periods of deliberate isolation, especially during the Edo period from 1603 to 1868, kept foreign DNA out. Modern Japanese people carry a genome that is about 90% unchanged from their ancestors 2 millennia ago. Korean and Chinese populations also show similar continuity. But Japan's island status pushed its score slightly higher. The top two are profound. But the number one population is still to come, promising to redefine understanding of human origins. The most genetically pure population on Earth was not where anyone expected. It was not in Europe, it was not in East Asia, it was the Andamanese. The Andaman Islands are a small archipelago in the Bay of Bengal. They are technically part of India, but geographically they sit closer to Myanmar and Thailand. The indigenous tribes of these islands, the Sentinelese, the Jarawa, the Ong, and the Great Andamanese, represent the most genetically isolated human populations on the planet. Their DNA tells a story so old it feels almost mythical. The ancestors of the Andamanese were among the very first humans to leave Africa. This was around 60,000 years ago. They migrated along the southern coast of Asia. They reached the Bay of Bengal. Then they settled on the Andaman Islands. After that, they stopped. They never moved again. They never mixed with other groups. They never met another human population in any lasting way for tens of thousands of years. Geneticists compared the Andamanese genome to ancient DNA samples from all across South Asia. They found something remarkable. The Andamanese are the closest living genetic match to the original modern humans who first populated Asia. They are not just isolated, they are a living window into what humanity looked like 50,000 years ago. This was before the great agricultural revolutions. It was before cities rose. It was before any of the genetic mixing that created every other population on Earth. Their physical features tell the same story. They have short stature, dark skin, and tightly curled hair. Their body chemistry is adapted to tropical island life. For decades, anthropologists assumed the Andamanese were related to African pygmies. This was because of how they looked. The DNA proved that idea completely wrong. They are not African. They are not Indian. They are not Southeast Asian. They are something older. This is a branch of humanity that split off from everyone else before any of those modern categories even existed. Their physical resemblance to certain African groups is not from shared recent ancestry. It is from preserving traits that the original humans probably all shared. Other populations slowly lost these traits as they moved into colder climates and started eating agricultural diets. The Sentinelese are the most famous of these tribes. They live on North Sentinel Island. They have actively rejected all outside contact. They fire arrows at every helicopter, boat, and person that approaches their shores. In 2018, an American missionary named John Allen Chow tried to land on the island. He was killed within minutes. The Indian government has since banned all approach to the island. They know the Sentinelese have no immunity to modern diseases. Any contact could destroy them entirely. The Sentinelese number, perhaps 50 to 150 people. The Jarawa number, around 400. The Ong are down to fewer than 120. The Great Andamanese suffered the most from British colonial contact in the 1800s. Now fewer than 50 remain. These are not just the genetically purest humans on Earth. They are the rarest. They are the most endangered. They are the most fragile. What shocked the scientists was not just that the Andamanese topped the ranking, it was what their DNA revealed about the rest of us. Researchers compared the Andamanese genome to every other population on the list. This allowed them to reconstruct the migration patterns of early modern humans with incredible precision. The Andamanese, in a sense, hold the genetic key to understanding who everyone else became. Every European trace of Neanderthal DNA, every Asian connection to Denisovan ancestry, every African genetic adaptation to malaria, every Native American link to ancient Siberian hunters. All of it makes more sense when measured against the baseline of the Andamanese genome. This is the closest thing we have to humanity before mixing began. The Stanford study revealed an uncomfortable truth. There is no such thing as a pure race in the modern political sense. The populations at the top of the ranking are not pure because they are superior. They are pure because their ancestors were isolated. They were trapped by oceans, by mountains, by thick jungles. Sometimes they simply chose to avoid the outside world. Every other human population on Earth is the product of mixing. This mixing was massive, constant, and always ongoing. Sometimes it was violent. Sometimes it was peaceful. The English are not purely Anglo-Saxon. The Spanish are not just Visigothic. Russians are not only Slavic. Italians are not only descendants of Romans. Americans are not any one thing. Indians are dozens of things. The Chinese, the Egyptians, the Mexicans, the Brazilians, the Iranians, when you look at their DNA, they are all beautiful, complicated, layered mosaics. Each group that passed through their lands left a mark. The Andamanese sit on their islands today. They are mostly invisible, mostly forgotten, mostly left alone. They do not know they are number one on a ranking. They do not know scientists call them the purest humans on Earth. They do not care about the categories the modern world invented. They simply continue as they have for 60,000 years. They are surviving, adapting, living. The rest of us scattered across the continents. We mixed and remixed, and mixed again. This is proof that humanity has always been on the move. There is no single bloodline. Every face you pass on the street is the result of a story so long and so complicated no one will ever fully tell it. Think about that the next time someone claims their family has always been from one place. Always does not survive contact with a DNA test. Go back far enough, and everyone is from somewhere else. The Vikings became Normans. The Normans became English. The English became Americans. The Americans became something nobody has even named yet. Every population is just a snapshot of a much longer journey. That journey is still happening. Right now, in this generation, more humans are crossing borders. They are falling in love across cultures. They are producing genetically blended children. This is happening more than at any point in recorded history. The mosaic is getting more complex by the day. The science is clear. The purest among us are the ones who stayed still. The rest of us, the mixed, the layered, the impossible to categorize, are the real story of what it means to be human. The paradox we started with, the idea that groups we thought were pure were actually the most mixed, now makes sense. It's resolved by understanding how genetic continuity works. It all comes down to isolation. If this kind of deep dive into human history is something you want more of, subscribe and tell me in the comments, what historical assumption do you think DNA testing will overturn next?